Hey everybody, welcome to another video. So in this video we are going to be focusing on another example of an excess script, but before we get into the particulars of that code, I want to go through a little context and a little backstory. So as you guys know, I make maps, and in testing said maps, I tend to play against the AI quite often. And it is oftentimes that I find that the AI is not really able to pose much of a challenge, even at the most extreme difficulty. So that kind of leads me to want to implement some kind of a handicap to make it more challenging for myself. Now, in the past, I've tried things like playing 4 versus 3, which it works, but sometimes it cramps up the map, and so that's really not much of an ideal solution. And the in-game handicap that was recently introduced isn't really super appealing to me either, since it basically changes too many things at the same time. As far as I know, it gives an economy bonus, a military production bonus, extra bonus damage for counter units, and extra building HP. So all that at the same time is kind of confusing and kind of breaks the mechanics of the game. So the idea I had was to do something a bit more old-fashioned. If you've been playing this game for a while, you may recall that in the past, if you played against the hardest AI, the AI would actually cheat. It would actually give itself 500 of each resource every age. So that kind of idea of giving the AI a resource bonus is a bit simpler, and with the excess script that we're going to do, we're going to try to make it as customizable as possible. So with that in mind, let us get started. Now, a lot of the time when I'm working with an excess script, I find that the basic structures I use in an excess script are usually common between different scripts. If I can give an example, a couple videos ago we went through an excess script for Mount Kailash, in which we looped through all players to check their current age in order to enable monastery technologies. So if we were to take that same kind of idea, looping through each player to check their current age, for our particular situation now, instead of enabling monastery technologies, we're just going to simply give extra resources to the player that happened to reach the new age. So rather than starting our excess script from scratch, I'm going to go ahead and grab this rule from the last excess script we did from Mount Kailash, which is going to be pretty helpful for us because it contains the basic structures for looping through all players to check their current age to produce some certain effects that we are only going to apply once. Now, we've already established that we're not going to be enabling monastery technologies, so we'll just delete these bits over here and over here. And what we are going to be doing instead is just giving players extra resources. So we will demonstrate how to do that in this init case that we can just do right away. And the syntax that we're going to use is XS effect amount is going to be cmod resource. The resource we're going to be modding is C attribute food. The operation we're going to be doing is C attribute add, and then the value that we're going to add is going to be some variable. We'll call it base. And then the player number, we'll just say is player 1 for now. So up at the top, we need to define how many resources we're going to be adding. So if I set up a variable of type integer, call it base, and set it equal to 500. So we've set up our variable called base. Let's change this rule to say extra resources, and we'll make sure we don't forget a semicolon. And then we can check what this does, and we make sure that in the map we're testing, we have include xs test.xs, which is this file name. And when we start the game, we can see that player 1 has been given an extra 500 food at the start. So that's pretty helpful. Now, when we're adding resources in the dark age, we can just use this init case over here because we're just going to enable it at the start of the game without checking for any criteria. But from the feudal age onwards, we need to make sure that we're checking that the feudal age, castle age, imperial age has been reached before we give those extra resources. So we had arrays set up last time to check whether a certain player had reached the castle age and imperial age, and we're going to do a similar thing, call this array F, to be a feudal age check. Feudal age array F array F. So this particular effect amount command is going to give us extra food in the dark age, and if I wanted to potentially add wood, gold, and stone, I could copy this a couple more times. And if I wanted to do that again, say in the feudal age, castle age, and imperial age, I could potentially copy this 3 more times. But that amount of code is going to get a little cumbersome and a little messy. So what we can do instead is just set up a function, and whenever we want to run this code, we just simply call that function. So now, a couple things to know about declaring our own custom functions is that they have to be declared before we reference them later on. So if I wanted to call a function that would say, I don't know, give res, I must have this function declared before I start to call it later on, which means I cannot define it down here. I have to define it up here before this rule, otherwise there will be a parsing error. So to declare a function, first we need to declare the type of return value, and since we're not going to be returning anything from this function, the return type is void. And then we have the name of our function, give res, which currently doesn't have any parameters, but we'll get to that later. Actually, we don't need a semicolon there. But we're going to, in brackets, put whichever code that we're going to be executing. So I want to give food, I want to give wood, I want to give stone, and I want to give gold also. So as soon as the dark age starts, what I'm going to do is going to say for player ID equals 1 to total players, I'm going to give resources to that particular player. Now, at this point, it's important to notice that in this effect amount function that I have, the last argument, which is which player is going to be receiving the resources, is still set to 1. So if we are looping through all the total players, it won't give resources to each player. It will only give resources to player 1 because that's what we've specified. So in order to make sure that the particular player ID is getting the resources, we have to set up some way to make sure that the correct player gets the resources. Now, we can't just say player ID, and you may think that because player ID is implicitly defined in this for loop, that when we call this function inside the for loop, that player ID would be recognizable over here, but that's not the case. What we're going to have to do is we're going to have to pass a parameter equal to player ID, which is going to be recognizable in this function. So Right now, this function has no parameters, because which is indicated by the empty parentheses. But if I give it a parameter to say player ID, and I can define the type of variable that is going to be passed, I declare it as an integer, and I call it target player, and I set that equal to 0. So now target player is going to be a parameter that is local to this function. So now if I replace this 1 with target player, now when this for loop is running through, it will take the value of player ID and it will pass it to this function in the form of this variable, which is target player. So we're going to try this, and we're going to see if all the players in the game get extra resources. So we can see that we've got extra resources for us over here. We can see that all of our scores are relatively the same, which helps indicate that everyone else got those resources too. And if we wanted to make absolutely sure, we can increase this to like 50,000, and then the score for everybody should be really high. So yeah, everybody's score is over 20,000, which indicates that we all got these extra resources. Okay, so let's scale this back down to 500. And then in a similar way in which we give players resources at the start of the game, we will give players resources again when they reach the feudal age, again when they reach the castle age, and again when they reach the imperial age. So let us test and see if this bit is working.
Mandat Willem. Bolden.
Ready, yay. Bolden.
So we can see that that bit is working too, since we got extra resources upon reaching the feudal age, and since we did the castle age and imperial age the same way, we can assume that it would work in that situation also. So we've made some progress up to this point, but at this point our script isn't really super customizable. The only thing we can customize up to this point is the amount of resources that we're going to be giving everybody per age, and we can't really decide who gets resources and who doesn't. And that was kind of the whole point of this, because if I'm playing against the AI, I don't want to be giving myself extra resources, I only want to be giving resources to the other players. So we're going to set up some extra parameters for ourselves. So we're going to declare these as type float, because we may want to include decimals for here. So if I say P1 factor, set that equal to 1, and I say P2 factor is equal to 0.5. So let's say that for every 500 resources that we give to player 1, we will give only half of that to player 2 because we are going to be using this multiplier of 0.5. And then similarly, we can have multipliers for all players in the game. So we have P3 factor, P4, 5, 6, 7, and 8. So what I'm going to do is I'm going to set the player 1 factor to 0, and all the others will be set to 1. So player 1 will get 0 resources, and then the rest of the players will get the full 500 per age. Now, in order to integrate this multiplier, what I'm going to do is I'm going to set up another array. So this is going to be array player factor. So basically, instead of having lots of if statements, I'm going to put all of these values into an array so that we can just multiply the base value by the target index. So this is the place where we are creating our arrays. So we're going to say, instead of array I, we're going to say array player factor, and it's going to be an array of type float instead of type integer. It's going to be player factor. And then in order to set the values of this array to the correct values up here, we will do that as follows. We will say XS array set float. So the name of the array that we're going to be modifying is array player factor. The index we are going to be modifying is we're going to start at 0, and we're going to set the value equal to the player1 factor. We have to remember that arrays start from 0 and don't start from 1. So if we want to set the values of arrays, we have to start from 0. So we have 0, 1, 2, 3, 4, 5, 6, 7. Player 1 factor, player 2 factor, 3, 4, 5, 6, 7, and 8. Now, it's important to notice at this point that the size of this player factor array is going to be equal to the total players in the game. So right now, if we look at our game, we have 6 total players, and in our code, we are attempting to access a total of 8 indices in the array. So we could tackle this in either of 2 ways. The first way is to put some conditionals around so that we say, like, if the total players is greater than or equal to 2, then we know that we have 2 players in the game and we can access the second index in the array. But the simpler way to do it is just make sure that instead of setting the size to total players, that we always set it to a strict 8. So if we try to access the 8th index, for example, it will always be there and it won't cause us any issues. So in order to apply this multiplier to the base value, we're simply going to do the base value times XS array get float. The array index we're going to be looking at is array player factor, and then the index of the array is going to be equal to the target player minus 1. Again, going back to the fact that arrays start counting from 0 and not 1, so if we are looking at player 1, we need to be referencing index 0, which is why we do minus 1. Make sure we close the parentheses over here, and then apply this multiplier to all the other resources that we're going to be adding. So to test this, I guess we'll set this back to be very high, and we'll see if player 1, which is me, still gets extra resources or not. Okay, so we can see that my resources are normal and my score is very low, but everyone else has a very high score, which indicates that they were able to get those extra resources. And at this point, we basically have all the tools we need to add whatever kind of parameters we want to customize this even further. So, for example, if I wanted to say that not all resources, food, wood, gold, and stone, are of equal value, so I could set up different parameters, multipliers for those particular resources. So I say float food factor is equal to 1. I say the wood factor is equal to 1. But I say if I want the stone factor, so stone is rather valuable, so for every 1 food and 1 wood I give, I want to add only half a stone. And then similarly, if I want a gold factor of 0.75, that means for every 1 food I add, I only add 0.75 stone. So if I were to take these multipliers and say base times the food factor, and then this is wood, so base times wood factor, base times stone factor, and then base times gold factor. So we can customize how many resources we're giving based on the particular resource. So we'll lower this and turn it back on for player 1. And we can see that we were able to add 500 stone, or 500 food, 500 wood, but we only added 250 stone because of that multiplier that we just added. And then we can take this even further by putting in multipliers based on what age we're in. So if I say float dark age factor is equal to 1, and I say float feudal factor is equal to 2, basically what this means is for every resource that I grant in the Dark Age, I'm going to give double that once we reach the feudal age, and I'm going to say is equal to triple in the Castle Age, and is equal to quadruple in the Imperial Age. So when we implement these multipliers, well, first we have to know what age we're in. So that has to do with over here. When we're calling the function over here, we know we're in the Dark Age. When we're calling the function over here, we know we're feudal, and then the castle, and then Imperial Age. So similar to how we passed a parameter to the function using player ID, we could pass another function or pass another parameter to say what age we're in. So if I say pass the parameter dark factor, I can set up another parameter in the function of type float, and I can call its name age factor, and then I can multiply this base value by the parameter, which is age factor. So when we call this function in the Dark Age, we will pass the parameter dark factor, which is going to be equal to 1. If we call this function in the feudal age, we will pass feudal factor, which is going to be equal to 2. And then similarly, we'll pass castle factor over here and imperial factor over here. So let's test that out and see what happens.
Bolden, ready, correct. Bolden.
So notice that we have given 500 resources extra in the Dark Age, and now when we reach the feudal age, we can see that we were given 1,000, which is basically double 500. And that's basically the end of the script. Basically what we have for us is just a resource handicap, which is very simple to use and very, very customizable. So thank you everybody for watching, and hopefully you guys have learned something here. I'll see you next time.